All right, Precal, here is a quick test review. First thing we've got, we're graphing y equals 1/3 x squared times x minus 1 times x plus 3 squared. First thing, let's pick out those zeros. So x equals 0, and that is a double root. X equals 1, that's a single root. And then x equals -3. That's a double root. So 1, 2, 3, 4, 5. This is a 5th degree function. It has a positive leading coefficient. So if it has a 5th degree with a positive leading coefficient, overall it will be an increasing function. So that means as far as end behavior, as x approaches -infinity, y approaches -infinity. As x approaches positive infinity, y approaches positive infinity. Increasing function overall. So let's plot these zeros and then let's talk about them. If we have a double root at 0, then the graph is going to bounce at 0. We also pass through 1, but we will cross at 1 because it has a single root. And then we also have a double root at -3, so it is going to bounce at -3. Once again, thinking about our end behavior, what's going to happen here? So it would behoove us to plug in x equals negative, how about -2, and that'll give us some direction as to where our graph is going to be in between 0 and -3. So let's plug it in here. So that becomes 1/3 times -2 squared is 4. -2 minus 1 is -3. That's helpful. That'll make the fraction cancel. And then -2 plus 3 is 1. 1 squared is 1. The 3's cancel. It is negative. We get -4. So we're at -2, -4. That's helpful. So once again, we know that it's going to bounce at x equals -3. So let's go ahead and let's start filling that in. We know that it's going to bounce at 0, and then it's going to cross at 1. So it would be kind of a mess to plug in maybe 1/2, but if we did plug in 1/2, I think I'll even, well, I can't use the calculator, so I won't use the calculator. I'll keep it for real. So 1/3, and let's plug in that 1/2. 1/3, 1/2 squared is 1/4. 1/2 minus 1 is -1/2. And then 1/2 plus 3 is 3.5. 3.5 is 7/2. So 7/2 squared, that's 49/4. So what do we end up with here? Well, 3 times 4 is 12. 12 times 8 is 96. So we're looking at -49 over 96. That is only slightly larger than 1/2, -1/2. So what is happening here? We're going down. So we are bouncing at 0, going back down, and then going up. So there you go. That is a pretty quick rendition of that graph with a bit of precision. What am I looking for? I am looking for end behavior. I am looking for bouncing or crossing. I am looking for the zeros listed. That's what I want to see when you give me a graph like that. Let's find all the asymptotes and the holes. So the first thing we're going to do is we are going to see if we can factor anything. So it appears in letter A that we can factor this denominator. It's x over x times x minus 3. And what do you know? We got x's canceling. And anytime a factor cancels, that's when we're going to have a hole. So our function simplifies to 1 over x minus 3. But we have a hole at x equals 0 because that's the factor that canceled. And the factor that remains on the bottom creates a vertical asymptote at x equals 3. And if we have the degree of the numerator less than that of the denominator, then we will have a horizontal asymptote at y equals 0. Now let's not stop there because let's find the location of the hole. If we want the location of the hole, we go to the simplified function and we plug in 0. 0 because that's where the hole is. 1 over negative 3. So our hole is at 0 and negative 1/3. Vertical asymptote at x equals 3. Horizontal asymptote at y equals 0. The domain is dictated by the hole and the vertical asymptote. So our domain here is restricted. It cannot include 0. It cannot include 3. So negative infinity to 0, union 0 to 3, union 3 to positive infinity. Hole, vertical asymptote, horizontal asymptote, domain. That's what I want to see when I ask you for the asymptotes and holes. Next, g of x. This particular function. This function has the same degree on the top and the bottom. Also, nothing factors. And if nothing factors, then nothing's going to cancel. That means there are no holes. But we have a horizontal asymptote at, remember, cover up everything except those leading terms. Negative 3x over 5x simply is y equals negative 3/5. So a horizontal asymptote at y equals negative 3/5. A vertical asymptote, set that denominator equal to 0. We have a vertical asymptote at positive 2/5. Remember, these are horizontal lines and vertical lines. Write them as an equation. We only have one vertical asymptote, so our domain will be all real numbers except 2/5. So negative infinity to 2/5, union 2/5 to positive infinity. Next, last, letter C. The degree of our numerator is greater than that of our denominator. Our denominator will also factor. So 3x cubed plus 1 over x minus 1 times x plus 1. Now, our denominator factors, but nothing cancels. So if nothing cancels, there are no holes. But do we have asymptotes? Yes, we have vertical asymptotes, 2 of them. One at x equals 1, one at x equals negative 1. We do not have a horizontal asymptote. We will have a slant asymptote because the degree of the numerator is 1 greater than that of the denominator. In order to find our slant asymptote, we need to do long division. So what do we have? We have 3x cubed plus 0x squared plus 0x plus 1 over x squared plus 0x minus 1. Remember, to do long division, you need every power of x represented. X squared goes into 3x cubed, 3x times 3x times x squared, 3x cubed, 3x times 0 plus 0x squared, 3x times negative 1, negative 3x. Draw the line, change all the signs. Cancel, cancel, 3x plus 1. X squared will not go into 3x, therefore this is our remainder. But if we're talking about asymptotes, the remainder is negligible, so just dump it. We have a slant asymptote at y equals 3x. Now let's write our domain. Our domain is everything but 1 and negative 1. So negative infinity to negative 1 to positive 1, and then 1 to positive infinity. So that is finding all the asymptotes and holes. Next, let's find all the zeros. So what I would do first is write your P's and Q's. Remember, this is your P, this is your Q. So your P's and Q's, P's over Q's, 8, factors of 8. 1, 2, 4, and 8, all over the first factor of 3, which is 1, 1, 1, 1. Then next, 1, 2, 4, and 8, all over the second factor of 3, which is 3. 3, 3, 3, 3. So now we've got all our factors, P's and Q's. Now let's take a look at the graph. And I've already got it plugged in, so checking it, 3x to the fourth, 11x cubed, 3x squared, minus 6x plus 8. When we take a look at the graph, we have a definite 0 at 1, 2, 3, 4. So let's start with 4, and let's divide. Our objective is to depress this quartic polynomial. So we want to depress it down from a 4th degree to a 3rd degree. So once again, we can see that we've got a 0 at 4. And of course, can I help you see it if I zoom in? Yes, there we go. 1, 2, 3, 4. All right, so let's depress it down by 4. So 3, negative 11, negative 3, negative 6, 8. Remember, that last column should cancel. Bring down, multiply, add, multiply, add, and multiply, and add, and multiply, and 0. That's just what we want. Don't lose that. We need it because we wanted to press it down again. Now take a look at my calculator. What I've got here is another 0, and that other 0 is between 0 and 1. So and it's closer to 1 than it is to 0. So keeping that in mind, let's look at our P's and Q's. Which one of these is close to 1? I'm going to go with 2/3. Let's depress it down by 2/3. Bring down, multiply, add, multiply, and add. And there we go. That's what we want to happen. Look at what remains. This is quadratic. This is 3x squared plus 3x plus 3, which we can easily deal with. So far, our zeros are 4 and 2/3. And we're going to get 2 more zeros from this quadratic function. So 3x squared plus 3x plus 3 equals 0. First thing I'm going to do, I'm dumping the 3's. X squared plus x plus 1 equals 0. Now, this is not factorable, but it can easily be solved by the quadratic formula. A equals 1, B equals 1, C equals 1. X equals opposite of B plus or minus B squared minus 4 times A times C all over 2 times A. Simplify. 1 minus 4 is negative 3, which makes sense because, once again, when we look at our graph, we only see 2 real roots, which means the other 2 roots have to be imaginary. So let's find them right here. So this is going to be x equals negative 1 plus or minus I root 3 over 2. What are our 4 roots? Our 4 roots are 4, 2/3, and then negative 1 plus or minus I root 3 over 2. 1, 2, 3, 4. There are all 4 zeros. Last problem. Given the zeros, 6 and negative 5 plus 2i, and f of 2 equals negative 636, find the function. So this is going to be a quick one because I've got 2 roots here, but of course this always comes in a pair, so we'll just put that plus or minus underneath there. This is going to turn out to be a cubic function. So first of all, x equals 6. That translates to x minus 6. Now let's deal with this imaginary friend over here. So if x equals negative 5 plus 2i, then x plus 5 equals 2i. Let's dump that I by squaring both sides of the equation. So x plus 5 times x plus 5 is x squared plus 10x plus 25. And 2i squared is 4i squared. And of course, 4i squared will become negative 4, which will then get added back to the left-hand side. So our missing factor is x squared plus 10x plus 29. And that is what we will be multiplying by. So we're close to our function. We just need to use the distributive property twice here and get f of x, and then we'll use f of 2 equals negative 636. X times x squared is x cubed. X times 10x plus 10x squared. X times 29 plus 29x. I like to line up my like terms. Negative 6 times x squared, negative 6x squared. Negative 6 times 10, negative 60x. Negative 6 times 29. 6 times 30 is 180. 1 less 6, that is negative 174. So x cubed plus 4x squared minus 31x minus 174. So that's f of x. But that's not totally what I'm looking for. I need to find the function that will be a multiple of this that will yield a point at x equals 2, y equals negative 636. So let's plug in that x value in the function and set it equal to negative 636. So we're missing that leading coefficient. So 2, x is 2. 2 cubed is 8. 4 times x squared, which is 4. 31 times 2 minus 174. There we go. So bringing in my handy dandy calculator. So 8. I'll let you see it. So 8 plus 16 minus 62 minus 174 is negative 212. So when I do all my simplification here, I get negative 636 equals A times negative 212. Hooray! When I divide by negative 212, A is 3. So if A is 3, I've now got to multiply my function by 3 in order to get my answer. So here goes. My new and improved function is 3 times x cubed, 3 times 4x squared, 3 times 31, which will be negative 93x, and then 3 times 174 is 522, so negative 522. There is the answer.